All right, in this video, we're just going to look at a few more examples of multiplying polynomials. They call them special, but we're not really doing anything different this time. It's just we'll look at some, I guess, specific examples of polynomials where something different happens. In terms of multiplying things, probably nothing new other than just recognizing, I guess, when something different might happen. So, for example, um, there's a product, special product called a sum and difference. The rule is if you multiply two conjugate polynomials, conjugate meaning one's minus and one's plus, but everything else is the same. So here's two examples of conjugates where the conjugate of p plus 5 is p minus 5. So something interesting happens. So let's try it. Let's try it with this x plus 5 times x minus 5. So like we've seen before, we have to take the x and multiply it by each thing in the second bracket. And then we take the 5 and multiply it by each thing. So x times x is x squared. Again, remembering that you have to worry about sign, number, and letter. X times a negative 5, it's a negative, a 5, and an x. And then 5 times x is a positive 5 and an x. And then 5 times negative 5 is negative 25. When you take a look at the product that you get there, we should combine like terms here. There's two x's, so I'll have x squared. Okay, minus 5, and I add 5, so that would be 0x. So I don't need to write anything for that, so I can just write a minus 25. So the special thing, I guess, that happens here is that whenever you multiply a binomial by its conjugate, what happens is that middle term cancels out or becomes 0 or it goes away. So you don't really need to know that. Like if I saw x minus 6 times x plus 6, I might say, okay, that's x squared minus 36. But typically to get there, I'm always doing that whole FOIL, first, outer, inner, last thing. And then I'll see this stuff in the middle and I can cancel that. So you don't have to do anything different than you have done before. It's just, I guess, sometimes if you recognize that you have a sum and a difference, that what's going to happen is the middle term is going to cancel out. I guess it's nice to recognize that. Here's a couple you can try. And press play when you've tried them. So I would get with this one 4x squared minus 6x plus 6x minus 9. These two middle terms, because these are conjugates, these two are going to cancel. A minus 6 plus 6 is 0, so I get 4x squared minus 9. That would be the product of those two. This one I just changed the order of them, that's fine, but I'd get 4 times 4 is 16, I'd get plus 4x, and then a minus 4x, and a minus x squared. So these two terms, again in the middle, because these are conjugates, they will cancel out to be a 0, so I'll have 16 minus x squared. In the next section, we'll want to go backwards. And so being able to see that here I've got the difference of two things that look like they're squared, like I have down here, that'll tell me what I can get back to originally. So in this section, we're going this way, we're multiplying. In the next section, we're going to take a product like this and see if we can get it back into the two factors that it started from. Okay, another special thing that happens is when you have two things that are the same. So if you have a plus b squared, that means you have an a plus b times an a plus b. When you multiply them, what you come up with is you square that first thing, so a is squared. You square the last thing, and then you multiply these two and times it by 2. That's sort of the pattern that you come up with. Again, I don't know if I would memorize that. I would just multiply it out and see what happens. So I'd y times y is y squared, then I'd get plus 3y, and another plus 3y, plus 9. And I look at the middle two, I can't cancel them out because they're the same sign. So it would be 3y plus 3y is 6y plus 9. So if you take a look at it, this was originally, you could have written it as y plus 3 all squared. So you could say y times y, y squared. 3 times 3, 9. And then y times 3 is 3y times 2. That's what this is sort of saying. You can see how it could be confusing to try and apply this rule. I guess if you do a ton of examples, you might get so that you might be able to go straight to there instead of using this step. You can skip that. Typically, I like just to FOIL, and you can. There's no reason why you can't. Here's something that you could try. So try and press pause, try and see what you come up with, and then come back. Okay, I assumed you tried them. That's what I got for both of those questions. Okay, the last sort of slide I wanted to look at is just putting all these products together. So if you see something like this, it's a monomial multiplied by a binomial, then you use the distributive property. So this would be 2x squared plus 8x. If you see a binomial times another binomial, you need to do that whole first, outer, inner, last thing. With this one, you can still do the same thing, but if you recognize it as a sum and difference, you could just write x squared minus 36 if you wanted to. But typically, I like to multiply it out and see what I come up with. This one, same thing. It's two of the same one, so a binomial square, they call it. You could write x squared plus 12x plus 36 if you've used that rule enough. And we did this one in the last section where it's a binomial times a polynomial, where you just have to take the x and multiply it by everything over there, and then take the 2 and multiply it by everything. Okay, so that's a special product section, nothing too different. It's just recognizing when special cases happen. Okay, hope that helps. Try some questions.